Hello GATE aspirants. Welcome to part 1 of GATE Classical Mechanics series. Question number 23. For the set of all Lorentz transformations with velocities along the x-axis, consider the two statements given below. If L is a Lorentz transformation, L inverse is also a Lorentz transformation, which is correct. If L1 and L2 are Lorentz transformations, then L1 and L2 is necessarily a Lorentz transformation. So both P and Q are correct, so option B is right. Next question. A particle is placed in a region with potential V of x where k lambda is greater than 0. Then we have to find out the points of stable and unstable equilibrium. This is the potential. Let us take first derivative. So dV by dx is equal to half into k into 2x. So half into k into 2x minus lambda by 3x square. So this is kx minus lambda x square. Let's equate it to 0. That will give us kx is equal to lambda x square. So that means either this can be written as, if we take x common, then k minus lambda x is equal to 0. So either x is 0 or x is equal to k by lambda. Now let us calculate second derivative, which is d2v by dx square, and that is equal to k minus 2 lambda x. Now d2v by dx square when x is equal to 0 is equal to, when x is 0, this is equal to k, and second derivative of potential at x is equal to k by lambda is equal to k minus 2 lambda into k by lambda. So k minus 2 lambda, which is minus k. Now this is greater than 0 and this is less than 0. So that means this is minima and this is maxima. Minima means stable point, stable equilibrium, and maxima means unstable equilibrium. So that means when x is 0, it is stable equilibrium, and x is equal to k by lambda is unstable equilibrium. So option B is correct. Next question. A pi zero meson at rest decays into two photons which move along x-axis. They are both detected simultaneously after a time t is equal to 10 seconds. So t is equal to 10 seconds. In an inertial frame moving with a velocity v is equal to 0.6 seconds in the direction of one of the photons, the time interval between the two detections is. So we want to find out time. So t1 is equal to t naught in bracket 1 plus v by c upon 1 minus v by c. So this will be equal to t naught is 10, 1 plus velocity is 0.6 c. So 1 plus 0.6 upon 1 minus 0.6. So this is 10 in bracket 1.6 upon 0.4, which is 4, and square root of 4 is 2. So this is 20 seconds. Similarly, for second case, so this is the case. One photon is going in this direction, another photon is going in this direction, and the inertial frame is moving with velocity v in, suppose, this photon. Then for this photon, velocity will be negative. So t2 will be t naught 1 minus v by c upon 1 plus v by c. So this is equal to t naught in bracket 1 minus 0.6 upon 1 plus 0.6, which is equal to 10 in bracket 0.4 upon 1.6, which is 1 by 4. So this is 10 by 2, which is 5 seconds. Now we want to find out time interval between these two detections. So t1 minus t2, which is 20 minus 5, is 15 seconds. So option A is correct. Next question. The Lagrangian for a simple pendulum is given by this equation. Hamilton's equations are then given by, this is L. So let us calculate P theta, which is equal to dou L by dou theta dot, which is equal to half m L square 2 theta dot, which is equal to ml square theta dot So from here we can write theta dot is equal to p theta upon ml square. That means theta dot square is equal to p theta square upon ml square square. Now L is equal to, L usually we write it as L is written as T minus V, that is kinetic energy minus potential energy. So this part is kinetic energy minus potential energy, and H is equal to T plus V. H is equal to T plus V. So that means this is equal to this half ml square into theta dot square, which is half ml square. Theta dot square is p theta square upon ml square square, that is kinetic energy, plus potential energy is mgl into 1 minus cos theta. So from here H is equal to p theta square upon twice ml square plus mgl 1 minus cos theta. So this is Hamilton. We want to find out Hamilton's equations, and Hamilton's equations are theta dot is equal to dou h by dou p theta, but we have already calculated it, which is p theta by ml square. That is the first equation. And second equation is p theta dot, which is equal to minus dou h by dou theta. So here we have theta, so this will be equal to this is minus sign, so minus mgl, minus sign we already have here, so minus mgl, and derivative of 1 minus cos theta, which is sin theta. So p theta dot is minus mgl sin theta, p theta dot is minus mgl sin theta, and theta dot is p theta upon ml square. So option A is correct. Next question. The Poisson's bracket between theta and theta dot is, so it is theta theta dot, and theta dot is p theta upon ml square. So this is equal to 1 by ml square, and here we have theta and p theta. So this is equal to 1 upon ml square, and we have the variables, corresponding variables are theta and p theta. So this is dou theta by dou theta, dou p theta by dou p theta, minus dou theta by dou p theta, and dou p theta by dou theta. Bracket. So this is, first part is 1, second part is 0. So this is equal to half ml square. So option B is correct. So these were all the questions from classical mechanics part from GATE 2010 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.